So today we are going to understand about how to unpack argument list. In the previous session, we have explored various concepts on how functions are defined, and today we'll see additional experiments on unpacking argument list, lambda expressions, defining annotations and functions, and so on. So now, in order to get started, let's quickly have a look how we can unpack argument list. The reverse situation occurs when the arguments are already in a list or tuple but need to be unpacked for a function call requiring separate positional arguments. So suppose you are given an argument in form of a list and you have to unpack those lists in order to quickly grab the individual argument, and you have to provide that argument to the function. For instance, there is a built-in function range which you all have explored. So range function expects separate start and stop arguments. So you can have a start element, you can have a stop element, which you can define in range. If they are not available separately, write the function call with the star operator to unpack the arguments out of a list or tuple. So let's quickly explore how we are going to do that. Now here, you can quickly see there is a function known as list. Within this function list, we have got a range object. This range object starts from number 3 and will end up at 5. So it is going to be I to j minus 1. So this is a normal call with separate arguments, wherein 3 will be provided, 6 will be provided, and you're going to get a list generated with the elements 3, 4, and 5. Now what next we need to do? In case you are going to get that argument, but suppose in case if you want to call arguments with unpacked list, then what you have to do? You have to give a range function with a pointer variable, and you are going to generate that output. So we are going to quickly explore that, how it is going to be done. So let me allow recording privileges to the participants. Okay, here. So now, as you all can see, you're going to unpack the argument list. You're going to call, you are going to call a function with the separate arguments, as well as you're going to call the arguments unpacked from a list of elements. Okay, so let's see how you're going to do that. Okay, let's go for it. So in order to get started, you're going to make use of collab.research.google.com. Let's go to collab.research.google.com, and we're going to write our scripts over here. So let me just put it on two different sites so that you all will be able to observe the code as well as you'll be able to implement the concepts easily. Okay, guys, so let's get started with a new Python 3 notebook. And we are exploring the concept of unpacking argument lists. Okay, so let's quickly define unpacking arguments, as well as we are going to understand lambda expressions. Post lambda expressions, you are also going to understand how we are going to write annotations for the functions as well as documentation strings. So to get started, let's quickly connect with Google Compute Engine backend. So we have started our Google Collaboratory. We are connected with Google Compute Engine, which offers us 12.72 GB of RAM and approximately 49 GB of hard disk space, wherein we can store our data and we can process it. So now the first thing which you're going to do is you're going to unpack list arguments. Okay. Now here, as you can see an example, suppose we are going to take the default example first, which is given in the documentation. Then we are going to test that with another example. Now, initially, suppose you have a function known as list. So you all know there is a function known as list, and what it can do, given the elements, you can actually create a list of the element. So this list function, it can create a new empty list for you depending on the number of iterables provided to it. So if you are going to give him a range object or a iterable element, then it is going to create a list of all those elements. Okay. So now let's quickly create an iterable. As you all already remember that we can use a range function to create an iterable, and we have already done a lot of examples on range. So initially, suppose you are going to create a range object starting from position number 2 and up till the position number 10. So starting position is going to be I, ending position is going to be J, and you're going to get a range object, which is an iterable, which will be created from value 2 to 9, from I to J minus 1. So now, once we execute this code, we are going to get a new list generated from the elements 2 up till 9. So let's quickly test that. So now you can see that we have passed a range function, and this range function is also an argument which we have given to the list function. So this is the regular way of giving an argument to the list object, and then you're going to get the elements created. Okay. But suppose now the objective is, suppose you are in a situation, I'll write that on a new cell. Everybody is clear up till here? All of you are clear up till here? Please confirm me on chat. Great. Now, what next we are going to do? We have added a new code cell, and now suppose you have an argument. Okay. You have a list of arguments, and to use them in function, you have to unpack it, to unpack the arguments. Okay, you have to unpack the arguments. Suppose, so how we are going to unpack? Suppose I have a list of arguments, and suppose it has certain values like 2, 3, 4, 5, 7, 8, 10, like this. Now this is an argument list. Now if I want to pass this argument list under the list function, then how can we do that? So if you pass this argument list under the list function, you can quickly see that we have passed that argument and we have got the element extracted out. Okay. But this is the common case wherein you have the argument available and you have given it to the function and it got printed. But now when we have to unpack it, okay, suppose we have to unpack the argument, okay, with respect to range function. So range, as you all know, range object, what it does, it gets a value of I and it takes a value of J. Okay. And suppose you have an argument available wherein suppose I value is going to be 2 and J value is going to be 10. Okay. This is an argument. So now what we need to do, once we are going to call list function, we are going to unpack this argument. Unpacking the argument means take the first value, give it to the argument number 1 of the function, take the second value, give it to the argument 2 of the function, and then you're going to get the output. So what does this mean? This means I'm going to make a list of elements and I'm going to call the range function. And within this range function, now what I want to unpack the list. To unpack the list, you're going to have, for example, you're going to have two elements. Consider I, consider j. This is an example which I'm showing you. So this argument will automatically be extracted into I, and the second argument will be extracted into j. This is what we need to do. Okay. So how you can do that? You can quickly pass the element, the argument element, with a star attached to it. Okay. You can pass the argument with a star attached to it. So when we give a star argument, this means it's going to be a list of arguments and we have to unpack it. Okay. So for every position, we're going to unpack the element and we're going to get that printed. So let's quickly check back. So how we are going to do that? So instead of calling I and j separately, what we will do, we are going to directly call pointer args. Okay. So automatically range is going to get two values, the initial value of I and the external value of j. I hope this is clear to all of you. Are you all able to understand? So now when we print here, as you can see, I have passed this list of arguments here and I have provided a star, which means this is a list argument and we need to unpack it. So once we unpacked, we got I value equal to 2, j value equal to 10, and we got this printed from 2 to 9, from I to j minus 1. If this is clear to everyone, please confirm me on chat. If you all have any questions, you can ask me. Everyone, have you tested this? Please confirm. Great. Now let's see. So let's take another function. Okay, and let's add a new code cell. Now here, I'm going to give you an objective. Let's say you're going to define a function profile, which will have the arguments. Arguments include name, age, number. Okay, three values you're going to provide: name, age, and number. So suppose you have created a function, define the function profile, and this function is going to receive three arguments. It could be a string, it could be age, it could be number. So as you already know, just to quickly give you a recall of how you call functions, I'm taking you to the previous session revision, wherein you all have created a lot of functions with a lot of arguments. Okay. So like this, we have individual arguments. You can define compulsory arguments as well as you can define optional parameters also. Okay. So let's say I'm going to take a function and I'm going to receive name, age, and number. Okay. And once this function is going to be called, we're going to print three statements. Let's say we are going to print name is, and we're going to print name. Second, we're going to print another statement. Let's call it as age is, and we're going to print the value of age. And finally, we're going to print number is, and we're going to print the number. So we do have a simple function created known as profile. Okay. Now when you need to call this function, let's call the function with regular arguments. So how do you call? You're going to give profile. You're going to give name, let's say Devanshu. I'm going to give age, let's say 29. And number, let's say I'm going to give it 965482537. Suppose like this. And when I call this function, so I'm going to get this function executed. Name is Devanshu, age is 29, and number is 965482537. Now, but if I need to unpack it from a list of arguments, okay? So now here we are going to define unpack arguments, unpack from a list of arguments. So let's say I've got a data variable, and within this data variable, I have given three values: Devanshu, age 29, and mobile number as 965482537. Okay. And now I would like to call profile function, and instead of calling data, I would like to use star data. So when I will call star data, I'm going to get all the arguments fetched out, and we're going to get the data printed. So now this time if I call, I get the similar output. Name is Devanshu, age is 29, and number is 965482537. Is this clear? Is it clear to everyone? Please confirm me on chat. You all are clear with how to unpack list of arguments? Great. So now we'll move to lambda expressions. Okay. So let's move to lambda expressions now. So what is lambda expression? Small anonymous functions can be created with the lambda keyword. Okay. So as of now, what you have been doing, you have creating functions with a name. Okay. So here we created a function where we defined a specific name to the function. Name of the function is profile. Then we have given certain arguments, and then we call the function and we got the output. Now, in case if you guys have to create anonymous functions, okay, what is the meaning of anonymous functions? Anonymous function is a function which does not have a name. So consider if you want to quickly make a function within one line of code without the name of the function, you can quickly create that with lambda keyword. This function returns the sum of its two arguments. So consider there is a function. मान लो आप एक कॉमन फंक्शन बनाना चाहते थे जिसमें आपने दो इनपुट्स लिए a एंड b और आपने उसका आउटपुट रिटर्न कर दिया a plus b कैलकुलेट करके. So you have got an argument a, consider it 2. You have got an argument b, consider it 3. Then the return statement will be a plus b, which is 2 plus 3, and we are going to get an output known as 5. Okay. So what we can do, suppose the default way of creating the function, let's call it as a named function. Named function will be created something like this: define add, and you're going to get the value a comma b, and you're going to return the value of a plus b. Okay. And if you call this add function anywhere, if you give the arguments like 2 comma 3, you're going to get the output as 5. But suppose I want to quickly convert this into an anonymous function. Anonymous function. And we also call it as a small anonymous function. Okay, so we can do that using lambda. So what we can do, we can call lambda, we can define the value of the arguments, and we can get the value whatever we want to get in return. Okay, is that clear? So this is called a named function. This is the format of the named function. Okay, we are going to use it shortly so that you will get to know how we are going to pass the values to the lambda and how we are going to get the output executed. So lambda functions can be used wherever function objects are required. Okay, so lambda functions आप कहाँ पे use कर सकते हो? जैसे मान लीजिए आपको कोई quick function execute करना है and you want to get an output and you want to keep it like an object, तो वहाँ पे आप lambda functions use कर सकते हैं. So it could be like a one-line function in case if you write anywhere in a program, we use lambda functions. They are syntactically restricted to a single expression. Okay, here. So they are syntactically restricted to a single expression. So this means whenever you are going to write a lambda function, it is always going to be a single line code. Okay. Semantically, so syntax कैसा होगा उसका? Syntax होगा single line code. और semantic क्या होगी? Semantic का मतलब होता है meaning of the function. So semantically, they are just syntactic sugar to a normal function definition. So suppose you are going to create a normal function and it is going to return an output. The same syntax and semantics will be followed with lambda expressions also, and you are going to get the value calculated. Okay. Now here, so you can see that like nested function definitions, lambda functions can reference variables from the containing scope. Okay. So suppose you're going to receive the value of x. Say, suppose here what they did, they have called a function known as incrementer. They have got the value of n, and you're going to return a value of lambda x colon x plus n. So whenever you're going to call this function with a value, it's going to increment it again and again. So let's say initially the value is 42. Okay. So once you have called the function f with a specific value, so incremental में हमने n ले लिया, अब जो भी वैल्यू डालेंगे वो x वैल्यू हो जाएगी, जो भी उसको फंक्शन के साथ में पास किया जाएगा. क्लियर? तो यहाँ पे आप देख सकते हो एक फंक्शन है, मान लीजिए मेक इंक्रीमेंटर के नाम से, जहाँ पे nth वैल्यू विल बी इंक्रीमेंटेड एंड इट विल बी एडेड टू द x वैल्यू. ओके, सो मेक इंक्रीमेंटर को एक वैल्यू मिल गया 42, वो हमने एक फंक्शन में स्टोर कर दिया f. नाउ दिस फंक्शन इज समथिंग लाइक लैम्डा x इक्वल टू x प्लस n. तो जैसे अब आप फंक्शन को 0 पास करोगे, so x is going to receive the value of 0 and x will be added to n. N is automatically 42, so you're going to get 42 in return. In the same way, if you're going to pass 1 to this x, so 1 will be added to the number 42 and you're going to get that value returned. Okay, so we'll see that how we are going to use these functions and how you can make use of lambda. In a great detail, we are going to do that. Okay, so let's quickly call this function. So यहाँ पे बनाते हैं हम एक. Everybody has got clear with what a lambda function is. A lambda function is a single line function wherein whenever you need to quickly write a function as an object, you can quickly create that in Python, and it is always going to be a single line of statement. You can pass n number of arguments to it, and you can quickly return the output out of the function, whatever you have created. So let's make a simple function. So here you are going to define, let's say you have a named function, make increment, and you are going to increment it by a value. Let's say nth value. Okay, and you're going to return another function, and let's consider this function as a lambda function, which is going to receive a value of x, and you're going to add this x value to the nth incrementation operator which you have provided. Okay, so now what is going to happen? So this is completely, it's going to become a new function. So what we'll do, we'll make increment. We make increment. Let's say we have passed in a value of 10. So when you run this function, this is going to become a return lambda function is going to be returned back to you. Okay, so you can see that make increment Okay, so now you can see that once we call this function make increment, you're going to get a function in return. Okay, make increment is a function which has automatically returned you a lambda function. Okay, so now what you can do is you can quickly store that into a lambda function, like let's call this LF. LF stands for lambda function. So lambda function is now an object. Okay, it's like an object function, and you can call this function like an object anywhere in the code. So now what you can do is, let's say you need to increment it by a value of 10. So if I pass, let's say 20. So if I pass 20, now this 20 is going to be given to this x value. And this is the argument. And this is the return function. So argument will go to the function here, where x value will be 20. And nth value we have already defined as 10. Okay, so 20 plus 10 will be added, and you're going to get a return statement as 30 if you call this LF function, if you call this lambda function. Okay, so can you see that? Is that clear? Are you clear with this function, lambda? So lambda is like a single line function, and you can call it anywhere. Great. Okay, so there are additional ways to call this function. So you can see that the above example uses lambda expression to return a function. Another use is to pass a small function as an argument. So what you can do is you can create a function and you can pass that function as an argument also. Consider you have a list of pairs. Okay, so in this list we have 4 tuples. Now here in the code we are trying to sort the pair. Okay, and the pair will be sorted with respect to a function. So we created a lambda function known as key, wherein the value of a pair is going to be passed, and the index value, that is the value at index number 1 of that pair, is going to be fetched out. Okay, and then it is going to be sorted depending on the key. So initially when you are going to sort it out, so the first value is going to be returned. Key will be with this key 0, 2, 3 and 4. So F in lexicographical order, F is the first element, hence 4 will be returned. Then O, P, Q, R, S, T will be returned. Okay, so how it works, let me just show you. So here let's have a look how we are going to use this lambda function in order to sort a list of elements out. Okay, consider you have got a list of tuples. Here is the first tuple. Consider you have got a value 1 and you have got this value 1. And you have got another tuple. Let's consider it as 2, and you are going to have a string statement as 2. Then you are going to have the third tuple. The third tuple is consider 3. Consider 3, and it's going to be, let's say, 3. And the fourth tuple is going to be 4, and let's call it as 4. Okay, let's change it to tuple. So as you all can see, you have got 4 tuples now, and if you quickly call this pairs list, you're going to get these 4 tuples printed. Okay, is that clear? Now what we have to do, using a lambda function, we have to pass each pair, each tuple as an argument. We are going to pass each element as an argument, each tuple as an argument. And out of that argument, we are going to fetch the value available at index number 1. And then we are going to sort it out. Okay. So how you can quickly do that? So for this, there is a function which which is being used. And with respect to key, there will be a lambda function wherein pairs will be passed, and out of each pair, every individual pair is going to be identified, and out of each pair we are going to get an element out of the list. So just to show you, here you can see that you have got this element out. Now you're going to call a sort function. Sort function has a function known as key, depending on which you would like to sort the data out. So sort, I'm going to show you first how sort works and how the key argument works. And within that key argument, we are going to pass each pair out of the list. So sort, what it's going to do, it's going to read all the elements, give every element to the pair, and then out of that pair, we are going to get the element out of that index value. Okay. Now let's see. So I'm going to show you how it's going to work. Okay, let's see. So let's say what we'll do. Suppose we need to write a function like this for pair in pairs. Okay, you're going to get each pair element out. So let's say I'm going to print the pair first, and then what am I going to do? Fetch index 1 from pair. So we're going to select the pair, and we're going to get the element at index number 1, and we're going to print that as well. Okay, let's see. We are going to print value at index 1 in pair. Let's just quickly print this function out. Okay, I'm sorry, I've written it pair. Okay, so now you can see. So what we are doing, we are going to read all the elements out of this pair. So let's say consider this is the first pair. We got this. This is the second pair. This is the third pair. And this is the fourth pair. Okay. And within each pair, once we access the index, this value is at index number 0. And this value is at index number 1. This is how we are going to fetch each element out of the pairs list. Okay, and then we are going to sort on the basis of the key value provided. So the key value is going to be 1, 2, 3, and 4. So when you're going to arrange all these in a lexicographical order, so 4 is going to be at the first position, 1 is going to be at the second position, 3 is going to be at the third position, and 2 is going to be at the fourth position, because in lexicographical order, F comes first, then comes O, then comes T with an H, and finally comes with T with a W. Is this clear to all of you? So this is one way of writing a multi-line function, but what we can do is we can quickly do that in a single line of statement with lambda function. Okay, and how can we do that? Let's have a look. So now suppose you had the same piece of code and you want to do this sorting in one single go, then what you can do is you can quickly call this function pairs.sort. And I'm going to show you how list.sort works. So it's a built-in function. So by default, the default parameter key is none and reverse is equal to false. What you can do is you can define a key value, and depending on the sort order which you are going to provide. So suppose you're going to pass in the value of 1, 2, 3, and 4 in the string manner, it's automatically going to arrange it in the lexicographical order. Okay. So now let's see. So you're going to call pairs.sort and you're going to pass in a key value. Now this key value, how it's going to be decided. So whenever you're going to call pairs.sort, it is automatically going to read all the elements. As soon as it reads the first element, we're going to pass this element as a lambda variable. So the lambda variable is going to be pair, and out of this pair, I'm going to get the first element, first index. Okay, element at the first index. So once we do that, So this function is going to be passed. 1, 2, 3, and 4 will be given, and we are going to get that sort printed out. So once we do that, we're going to get a sort list. We can store it into another list wherein we are going to get the elements printed, and we can get the printed object out. Okay. So now once this is sorted, now what you can do is you can quickly call the pairs out. And once you call the pairs out, you can see that you have got the list sorted. Okay. So initially the list was given as 1, 2, 3, 4. Now once we have passed it as a pair, you can see that it is arranged in the same lexicographical order. Okay. So each pair, so here we have fetched 1 first. So 1 being the second element, we got 4 from here. Hence the 4 has got to this position. Then you have got 1 at second position. Then you have got 3 at the third position and TWO at the fourth position. Okay. Is that clear to all of you? So with Lambda functions, what you can do is you can quickly customize a multi-line function into a single line function, and you can quickly get the output. Is that clear? Please confirm me on chat if you are clear till here. Okay, great. Now let's go to the next piece of code. Now here, once you're done with this, now we are going to understand documentation strings. Okay. So documentation strings is pretty simple. Just you need to use a triple quote and you can quickly comment anything in Python. So here are some conventions about content and formatting of documentation strings. The first line should always be a short, concise summary of the object's purpose for brevity. It should not explicitly state the object's name or type. Since these are available by other means, except if the name happens to be a verb describing a function operation. Guys, you go through with this definition for a moment. I'll just join you shortly. Okay, everyone. So as you can see, whenever you're going to write a documentation string, the first line is always going to be a short, concise summary of the object. And you don't need to define it explicitly. There are other ways to define it. The line should begin with a capital letter and end with a period. So whenever you're going for an official documentation, you have to follow this documentation string convention, because whenever you are going to work in a team, then it is very important that your code should be understandable by other developer. Otherwise, in explaining the code, you have to waste a lot of time. So it's always a good idea to document your code so that anybody who is going through your code will be able to understand it and will be able to integrate in your code. Okay. So standard documentation string format uh, has to be followed whenever you create a function. So now you can see that here you can quickly create a documentation string with a triple quote, and you can see that do nothing but document it. Not really, it doesn't do anything. So whatever function you're going to define in, okay, and whenever you're going to print the document for that specific function, you're going to get that output. It's like the help convention which you're going to give. Okay. So let's quickly have a look how we're going to do that. Okay, we'll go here. So now let's see. So suppose I'm going to perform this demo on documentation string. And suppose I created a new document known as a new function known as add, which is going to receive two integers a and b. So I've defined this string here, addition function. Okay. You're going to get the addition function. And now let's quickly define it something like this. So post addition function. Now I'm going to define this function will add two arguments and will return a sum of arguments provided. And I can quickly define syntax. Syntax could be add when you're going to give it a comma b, and what it's going to do, it is going to return a plus b. Okay, or you can also define it, it is going to return an integer with a format a plus b, kind of this. So I've made a documentation string for this function, and post this documentation string I have created my function. I've called it return a plus b, and that's all. Okay, so now I've got this function ready. So once I executed this, I've got this add function ready. Now what I can do is I can quickly print the documentation of this. So you can quickly go to print function. You can call your function add, and out of that add function, what you can do, you can quickly check back the documentation. Okay, so here is the documentation for your add function, and there are various other options which you can use with add. Okay, and here are the options. You can see the annotations, you can see the call, class, closure, code, and a lot of individual stuff for every individual function. Okay, so dictionary, directory, documentation. So we want to access this documentation. So once we do that, we click here. So you got this documentation return. So this is going to be an addition function. This function will add two arguments and will return a sum of arguments provided. Syntax will be this and return will be this. So can you see that? You can quickly grab the definition of a particular function so that any of the user, those who is working with your code in Python, and if he quickly wants to get a help out of the function, he'll be able to quickly get that out of the document feature or attribute. Is this clear? Are you all clear with this part? How you can quickly add a documentation to a function? Please confirm me on chat if you all are clear. So you can add documentation strings. Great. So now you know how to define functions, how to unpack the list of arguments, how to pass arguments in a different format, how to make use of statements like continue and pass. And there are so many other stuff you have already understood. You know how to document a function in a good way so that it can be used by other developers. Now we'll reach to the annotations. Okay. Function annotations we are going to do. So what is a function annotation? Let's have a look. Okay, now, so function annotations, how we are going to do? Function annotations are completely optional metadata information about the types used by the user defined functions. Okay, so there is an official documentation available for defining function annotations at PEP 3107 and PEP 484. You can explore that. Now, annotations are stored in underscore annotations attribute of the function as a dictionary and have no effect on any other part of the function. So it's like a document which is available. It can only be accessible whenever you are going to call the annotations attribute, and you can print that value out. Annotations are majorly used to describe the information about type of the different types which has been used within the functions. Okay. So parameter annotations are defined by a colon after the parameter name. Okay. Followed by an expression evaluating to the value of the annotation. So there will be two things. Suppose you have provided a parameter, then you can quickly define the type of that parameter by providing a colon. Okay, somewhat like this. So let's say you have defined a parameter HAM, and if you want HAM should be of string type, so what you can do is you can use a colon and you can define the str, which will define that okay, HAM is going to be a string function. Okay, so this is how you can quickly do that. As well as in case if you want to define a value to this annotation also, so you can also create an expression would be something like wherein you will have a left hand side equal to right hand side. So this is going to be an expression. Whatever syntax you would like to pass it as a value, you can do that. And again, return annotations are defined by a literal. Okay, so the output return annotations mean what is going to be the output of this function, so that you can use with a with this arrow literal. Okay, followed by an expression between the parameter list and the colon, denoting the end of the defined function statement. Okay, so now you can see that the following examples has a positional argument, the keyword argument, and the return value annotated. Okay, so what all we have, let's have a look. So we have got a function defined. We have got HAM as string, eggs as string. Then there is an expression that string is going to be eggs. Okay, it should be like a value like this. Then you are going to return the statement. It's going to be a return string. Then in the annotations, we have got that printed, that okay. Once we printed F annotations, we are going to get the value out. You're going to print the arguments, what is the value of HAM and what is the value of eggs, and then you can return HAM plus eggs, both the values can be printed. So once the annotations has been printed, you can see that HAM is going to be of string type. The return type is also going to be string, and followed by you're going to have a eggs, which is going to be of class string type. Okay, so we have got this value printed, followed by whenever we have printed the arguments, so ham and eggs, these were the arguments which has been given. So we got these values out, followed by the values returned within the ham. So whenever you're going to call this function, you're going to call, you're going to give a value, and that value is going to be printed out. Okay. So here, this is a compulsory parameter, which we have given here, spam, and this is a given argument, which is like a optional keyword based argument, which already the value has been given here. So this is how we can quickly print the annotation. So let's have an example. Let's print that here. So what you're going to do, you're going to create function, okay, functional annotation in Python. So this annotation in Python, let's have a look. So to define a function, let's say I've defined a function known as profile, and I've given him an argument known as name. And in order to define it, that it is going to be of string type, I can quickly use a colon and I can define it's going to be of string type. Okay. Another, let's say I have integer type. Okay. Age is going to be of integer type. Suppose I would like to give a fixed value to this age, or else a default value of an age. So consider the default value of an age is going to be 18. Okay. So in case if I have not passed age, it's automatically it's going to be printed as 18. Similarly, I've got a number, and I've called it as string, and I've given a specific number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a default number for this function. Then I have defined the output is going to be string type for this function. The output is going to be string type for this function. Okay. And let's quickly define it. So let's say I'm going to return a function and I'm going to call it as name. So now you can see that your function profile is created. You've got a new function created, and the output of this function is going to be, it is going to return the value. Okay, is this clear to everyone? We have got this function created. Now what am I going to do? Now I'm going to check the annotations out of it. So suppose we are going to print the annotations now. Print the annotations. We're going to call the print function. We're going to call this function profile. And out of this profile, you're going to print the annotations out. So once you print the annotations out, you're going to see that we have a variable which is of name. The name is of string type, age is of integer type, number is of string type, and the final output is going to be a string. Okay, is that clear? Similarly, if you execute this function profile and you call it as Devanshu, okay, let's change this function a little. Let's call this, we are going to print all the three values, name, age, and number. So I'm going to concatenate the age as well as the number. Okay, this is going to be a string. Okay, we'll do one thing. We'll call a string function and we are going to convert this age into a string, and we are going to print the complete string in return. So I have updated this function. Now when I'm going to call this function profile Devanshu, you can see that only one parameter is given, Devanshu, which is the name parameter, which is of string type. Okay, you can see that this is printed along with the default parameters also. So we have given the default parameter 18 to the age and a default parameter 9999 to the number. So even if we have not provided it in the function, it got printed. But somehow, if I am going to replace this value, let's say I'm going to say age is going to be 29, and I'm going to say number is going to be 9654, it's going to be a string, 9654825370. And if I run this function now, this time you're going to get the updated values. So instead of 18 and 9999, this time I have got my values from the values provided. Okay, and you have got the complete annotation printed as well for your function. Okay, I hope it is clear to all the participants that how functional annotations work. So you can quickly define what kind of arguments you're taking in, what kind of output your function is going to generate. Is that clear? Please confirm me on chat if you all are clear with documentations as well as the annotations. Okay, great. So now we'll switch to the next segment, which is the coding style in Python. So here is something which you all have to quickly read out. This is the documentation part. So you all have to read about intermezzo coding style. Okay. So now, since you are ready to write longer, complex functions, it is good time to talk about coding style. Most languages can be written or more concise, formatted in different styles. Some are more readable than others. Making it easy for others to read your code is always a good idea. And adopting a nice coding style helps tremendously for that. For Python, PEP8 has emerged as the style guide that most projects adhere to. It promotes a very readable and eye-pleasing coding style. Every Python developer should read it at some point. Here are most important points extracted for you. So use four-space indentation and no tabs. So whenever you write a Python program, use four-space indentation. Four spaces are a good compromise between small indentation. It allows greater nesting depth and large indentation. Tabs introduce confusion and are best to leave out. Okay. So whenever you're going to write a Python program and you have to use indentation spaces, always try to use four-space indentation. Okay. It's going to be the best Python style, and the Python style is PEP8. So if anybody asks you, in what Python style do you code? So you can quickly say, I code in PEP8 style, which is more developer friendly, and everybody will be able to read out my code well. Is that clear? Are you all understanding the point? So whenever you are writing a long piece of code or a long line, it should not exceed 79 characters. So in case if your lines are exceeding 79 characters, make it a multi-line code. So this helps users with small displays and makes it possible to have several code files side by side on larger displays. Okay. Followed by use blank lines to separate functions and classes and larger blocks of code inside functions. So whenever possible, put comments on a line of their own. So whenever you write a line of code, it's always a good idea to make a comment on it so that users will be able to understand what you're doing it. You can use documentation strings, which you already got to know how you can create a documentation string with a triple quote. You can use spaces around operators and after commas, but not directly inside bracketing a construct. You can name your classes and functions consistently. The convention is to use upper class, upper camel case. Okay. So whenever you're going to create a class name, it's going to be an upper letter. And whenever you're going to create functions, it is always going to be lowercase with underscores. So whenever you're trying to create a function with the lowercase with underscores. And whenever you're creating a class name, it should be upper camel case. Okay. Upper camel case is something like each word will be appended to each other and the first letter of each word is going to be an uppercase letter. Okay. Always use self as the name for the first method argument. Okay. So this is how you can follow the style and you will be able to write better Python codes. And these Python codes are going to be more developer friendly. So till now here, you guys are done with how Python programming is done. And post this, now you guys will be reaching out to the next important segment. And we'll quickly see that. We'll go to table of contents. We are done with the control flow statements and how to define the functions and all that stuff. Everything is being done here. Let's go to the tutorial page for Python. Okay. So till today, you guys are done up till this fourth part, control flow statements and all and every thing we have done till coding style. Now in the upcoming session, we are going to get started with data structures on Python. Okay. So you're going to explore about lists, you're going to explore about stack, queues, comprehensions, list comprehensions. And I believe we have done basics on list as well. So further in the upcoming class, we are going to do that. Before we proceed here, I would also like to give you a quick link to what all you can quickly follow post today's session. I'm sharing a link with all of you, the list which we have already covered in a great detail. I would like you all to observe that. I'm sharing the link with all of you. Okay, here. So I do have
know of one. That's why this is one of the best apps.
So I'm sharing two URLs with you all on chat. List index 2 and list index 3. Both these sessions you all have to observe today. Okay, so you all are going to observe both of these sessions today, and once you are done with that, let me know, so that in the next session we are going to quickly explore list shortly for 4 or 5 minutes, and we are going to start with machine learning tomorrow. Okay, so as of now you guys are done with various important structures like how Python works, how functions are defined, the complexity issues, and various other things we have already covered. So tomorrow we are going to have a discussion on data structures. So before that, I want you all to cover up all these concepts today, which I have shared the links. And once you guys are done with this, tomorrow, day after tomorrow, or else in the next session, we are going to get started with machine learning. So I hope this is clear to everyone. You are going to complete an implementation today with the list and dictionary, both the video series which I have shared with you. And post that, we are going to have a complete discussion tomorrow, followed by, if anybody has any questions, please ask. By the time I'm sharing the script code with all of you, so that you all can observe what all we did today. Okay, so you guys are done with 4 important concepts, wherein you got to know how to unpack list arguments. Post unpacking, you got to know about lambda expressions. Post lambda expressions, you have got to know how you're going to perform documentation strings and how you can use functional annotations, along with PEP8 coding style in Python, which makes your program developer friendly. And here I'm sending the code on chat as well, so you all can quickly observe the code which we have used today. Any questions, anyone? So that's all for the day. We'll catch up tomorrow morning, and we'll start with data structures, and we'll end up data structures tomorrow, so that we'll be ready for introduction to machine learning in the upcoming session. Thank you so much, everyone, for being available.